This is the mock exam solutions for advanced trigonometry and Voronoi diagrams. So, first problem. The diagram below shows a pizza with center O and radius R. The length of the crust arc ABC, which is this here, is 10 centimeters, and angle AOC is 25 degrees. What's this? Okay. Find the radius of the pizza R. Okay. So the first thing we're going to do is we're going to go look at the formula booklet, and the formula booklet has a way of finding the length of an arc from the angle, the central angle, and the radius. Okay, and that formula is equivalent to alpha divided by 360 times 2 pi r. Okay, I don't remember exactly what the formula booklet says, but it looks something like this. It might be arranged slightly differently, but there's 360 in the denominator. And then you're going to put the angle 25 degrees into alpha. And then you're going to put the radius into r. And here we don't have a radius, okay? Now we know that the crust arc is 10 centimeters. So we're going to put that the length of the arc is 10, and then this becomes kind of like an algebra problem, right? So let's fill in the 25, 360 times 2 pi r equals 10. So I think the easiest way to do this algebra problem is to take all the parts that are numbers, everything except for r, combine them into one number so that the algebra is a little bit easier. So what I'm going to do is I'm going to multiply 25 times 2 pi r. Remember, pi you can get by pressing second pi. And that's the numerator, right? 25 times 2 times pi. And I'm going to divide that by 360. And that gives me 0.436. So this is actually equal to, 0.436 r equals 10. And so now, to find the result for r, I can divide both sides by 0.436. And I get r equals 10 divided by 0.436. And the answer is 22.9. So this pizza has a radius of 22.9 centimeters. Next part, it says find the area of the pizza slice sector OABC. Okay, so basically what it's asking for now is, what is the area of this region here? Okay, and in the formula sheet, there's a formula which tells you how to find the area of a sector. And what that looks like is something like alpha over 360 times pi r squared. Pi r squared being the area of a circle. So in this case, now we know what r is. It's 22.9. So we're going to put 22.9 in here, and we know that 25 degrees is alpha again. So we put 25 divided by 360 times pi r 22.9 squared. So let's see what that is. So let's just multiply all the top numbers, which are these, and then we'll divide by 360 at the end. Okay, it's better to multiply all the top numbers first and then multiply or divide by 360 at the end. 25 times pi times 22.9 squared. And then I divide by 360 at the end. So this answer is 114.4, or with three significant figures, it's just 114. And this would be centimeters squared if you want to put the units, but if all the units are centimeters, you don't need to put the units for every single one. Okay. Okay, by the way, this radius is 22.9 centimeters. But again, in this class, as long as the units are not mixed, you don't need to put the units for all your answers. Okay, let's look at number 2. Let f of t equals a sine bt plus d, where t is greater than or equal to 0, represent the height of water in inches in a tide pool t hours after midnight. The height of the water at midnight is 22. Okay, the part of the graph of y equals f of t is shown below. Okay, this is kind of different than you're used to maybe. You're used to always seeing x here. This is just t. Okay, so like everywhere you normally see x, there's t there. T is used often when you think that the x-axis is going to be time. T stands for time. Okay, so here we have this obviously, sine curve, and here's our model. And what we're going to do is we're going to try to figure out what a, b, and d are to fit this model based on what they told us. They already told us one important clue, which was that at midnight, which is time 0, the height of the water is 22. Okay? All right. The other thing they tell us is at time equals 3, there's a maximum value of 29. That's right there. And at t equals 9, there is a minimum value of 15. Okay, 15. Okay, and this is 9, and this is 3. Okay, so that's what we got from the information here. It wants us to find the value of a. Okay, and there's a couple ways of finding a. One is you could take the max height, which is 29. You could take the min height, which is 15, and you could subtract those because the formula, and this isn't on the formula sheet, but maybe it's on your note sheet, max minus min divided by 2. So the way you find it would be 29 minus 15 divided by 2, which is 14 divided by 2, which is equal to 7. So that is the answer for A. Another way you could look at it is if you can already see that the mean line or the middle, the center line here is at a certain level, you can count the difference between the center line and the max point. And we already know that the sine curve seems to start here, and let's verify that. It says that the level of water at t equals 0 is 22, and do you see how 22 is exactly in between 29 and 15? 29 minus 7, 15 plus 7. So we can see that actually the middle of this curve is at 22. So we could take 29 minus 22 or 22 minus 15, and we could also get the A value of 7. Find the value of B. Remember that B is equal to 360 divided by period. In your notes, you can also write the opposite function, which is period equals 360 divided by B. Both are true, okay? Use whichever one is more convenient. If we're going to find the value of B, this is more convenient. What is the period in this case? The period would be the length or the width of the function from beginning to end. And unfortunately here, this is not the end of the function, right? It should go up a little bit more, and we can't really see how far it's going to go up after we cut off the graph. So in this case, one of the things you might do is use half a cycle to determine how wide the whole cycle is. So if you have a whole cycle, then you figure out the entire width of the whole cycle. But if you only have half, you could just figure out the width and then double it, right? So what are typical half widths that you might see? You might see just the upper lobe. You might see the lower lobe. And in this case, you have like the middle part of it, right? So like you have like from that piece over to here. So this is also half, right? If you take the max point to the midpoint, that's also half of a width. So let's do that. We'll go from here to here and check this width. So we can see that this point M is actually at x equals 3, t equals 3, and the minimum value is at t equals 9. So this width here is actually 9 minus 3, which is 6. So we just need to double that. That'll give us the period. So the period is equal to 6 times 2, which is 12. So our period is 12, so we're going to use this formula here. So B is equal to 360 divided by 12, which is equal to, if we put that in the calculator, it would be 30. So the B value is 30. Finally, find the value of D. Remember, the D value is just the center line value. I forgot what they call it in our chapter. It's called mean line, center line, and whatever they called it in the packet, which they called it something I wasn't used to. So what is the height here? We already know that it's 22, right? So the answer for D is 22. Okay. If they ask you for the equation of the mean line, then you would say y equals 22. But here they didn't ask us for the equation of the mean line. They only asked us for the value of D, 22. Okay. All right. At what time during the interval shown does the tide pool water height return to the original height of 22? Okay, so there's two ways to do this. One is we could say, okay, it starts out at 22, it goes up and comes back down. At some point, it's going to hit 22 here again. You can actually see that if this is the beginning of the cycle, this is the middle of the cycle. And remember, the whole cycle is 12 long. The period is 12. So to go from here to here, it's 6 wide. So at what time does it return to the original value of 2? T equals 6. Okay. How would you do that with the calculator? You could draw the function. And I'm going to draw the function using all the values I just computed. So 7 times the sine, and then the b value is 30. T plus D. Okay, so I'm going to type all those in. So 7 sine 30x, because you can't put T in here, plus D, which is 22. And I'm going to change the mode of the calculator to degrees. Super important. And then I'm going to graph it. Okay, and actually, I think it's off the screen because look how high it is. It goes to 24 and there's only 10 here. So let's change our window size to be exactly like this one. So we'll go from 0 to 10 on the X and we'll go from 0 to 30 on the Y. Let's go to Window. And we'll go from 0 to 10 on X and we'll go from 0 to 30 on Y. And then we'll graph it. Okay, so this is exactly what we have here. And then we're going to make a second function, which is going to be y2 equals 22, to see when the blue function crosses y2. So we'll go into y equals, and we'll change the second function to be 22. And then we're going to graph both. And what we want is when the blue function goes back to 22. It starts at 22, and then it hits 22 again. How do we find this point? We could do second, calc, intersect, which is number 5. And then the first curve is the blue curve? Yes, enter. The second curve is the red curve? Yes, enter. You're always going to just hit enter twice if you have exactly two functions in y equals. Last thing is guess. There's only one intersection close to here. We need to make sure that the cursor is over here and not here when we do the guess. So make sure that you move it over to here if it happened to be over there instead. And then you hit enter, and then it chooses the intersection that's closest, which in this case is 6, 22. So the x value is 6, or the t value is 6. Okay? All right, let's go to the last one. The pizza restaurants A, B, and C are located as shown in the grid map below. The line shown on the grid is the Voronoi diagram border between A and B. and it's given by this equation. So this line here is given by this equation. What they want us to do is they want us to find the midpoint first between A and C. Okay, it would be around here, right? It's kind of hard to see because this is a decimal, right? We're not going to be able to graph it perfectly. We're going to need to use the calculator to find the midpoint. Do you remember how to find the midpoint with the calculator? Yeah, that's right. It's stat edit. We're going to put in stat edit. We're going to put the coordinates of A and C. The coordinates of A we can just get from the graph. This is a 5. Let me make it a little bit bigger, and then I think. Okay, so this is 5 and this is 5. So the A value would be 2, 5. So I'm going to put that in the calculator. 2, 5 for the A value, and then for the C value it's 6, 3.5. 6, 3.5. Okay, and then I'm going to do stat calc 2var stats to find the mean point, or the midpoint. Mean point, midpoint, same thing. L1, L2 blank is what we want, blank for frequency list. And my X bar is going to be 4 and my Y bar is 4.25. So this midpoint that I have here is 4, 4.25. Okay, that's the midpoint. And so I'm going to write it down here too, 4, 4.25. And then I'm going to go to the next section, see what they want us to do this time. Okay, hence find the equation of the Voronoi diagram border. What does it say? Between A and C. So the Voronoi diagram border between A and C, we know that the Voronoi diagram border is going to be perpendicular to the line that connects A and C. Okay, so what is the slope of this red line? To find the slope of the red line, we're already halfway there because we already put the A value, the A coordinates and the C coordinates into stat edit. All we need to do now is take our stat edit values. You can see that we have A across the top and C across the bottom. We're just going to do stat calc and linreg, which is option 4. And if we do linreg, it'll give us the equation of the line which goes through there, and as a byproduct, it'll also give us the slope. So we put L1, L2 blank, blank into frequency list, enter, and there we go. The A value, or the slope, is negative 0.375. Negative 0.375 is the slope. Okay? Now, we want a line that is perpendicular to the red line so that we can find the Voronoi diagram border between A and C. So let's find the perpendicular slope to negative 0.375. How do we do that? Okay, so we have negative 0.375 as our slope for the line connecting the 2 points, but what we want to do is we would like a perpendicular. I'm going to just do something here. The green line is the perpendicular slope. I'm going to put negative 0.375 in red so that you know that that's the red. Okay, so the original slope is negative 0.375. In order to find the new green slope, what we do is we take negative 1 and divide it by the old red slope. So we're going to do negative 1 divided by, and then we're going to put negative 0.375 here, and then that's going to transform it into a perpendicular slope to negative 0.375. Okay, where did we get the red slope, negative 0.375? We got it from stat calc linreg. So let's go to the calculator, and we're going to do negative 1 divided by negative 0.375. And it gives us positive 2.67. Oops. Let's use green. Oops. 2.67. What are we going to do with this green slope? We're going to put it into point slope form. Okay? So point slope form looks kind of like this. Y minus y1 equals the slope times x minus x1. You can copy this out of the formula booklet. What are y1 and x1? They are the coordinates of the midpoint, which is 4, 4.25. Where do I put the 4 and where do I put the 4.25? The 4 goes in the x1 and the 4.25 goes in the y1. What about the m value? The m value is the slope, which here we found out was 2.67. So it's 2.67 times parentheses x minus 4 on the right side. On the left side, we have y minus 4.25, and we're done. That is the equation of the Voronoi diagram border. It's in point-slope form, okay? Last thing, a new taco restaurant D will be built at a location exactly in the middle of the 3 pizza restaurants. At which coordinates will it be built? Now, this is the toxic waste dump problem. The toxic waste dump should be located at the vertex of the Voronoi diagram. In this particular case, the vertex is going to be at the intersection of the point they gave, the line they gave us, and the green line, which is the other border. Okay, so what we're going to do now is we're going to find out what this intersection is. How do we do that? Well, first of all, we're going to need to know the form of this equation, here, which we can put in the calculator. And we can't put this in the calculator as is because look, it doesn't have y equals by itself. So what we're going to do is we're going to add 4.25 to both sides. If we do that, we end up with y on the left by itself because we added 4.25 to cancel out the minus 4.25. And then we're going to add 4.25 on the right side too. So that gives us an equation which we can put in the calculator. It's ready to put in the calculator. What other equation are we going to put? Well, we want the equation of this dotted line, which, remember, it's right here. So let's put those two equations in the calculator, and then we'll find the intersection point. So we go to y equals, and we're going to clear these out. And the first one's going to be negative 0.25x plus 3.375. So negative 0.25x plus 3.375. And then the second function is going to be 2.67 x minus 4 plus 4.25. And we're going to do a graph of that. Okay, so we're going to have two lines intersecting. And then we're going to find this, we're going to find that point there. Second, it might not look proportional to the original picture, but it's because, look, the y scale is all condensed here and the x scale is not. So I know it doesn't look right. So we do second calc and then intersect, which is option 5. And then it's going to ask you, do you want the first curve to be blue? Do you want the second curve to be the red one? And then it wants us to give it a guess that's close to this intersection. Basically, if you have two lines intersecting, you don't really need to worry about any of those questions. You just hit enter 3 times. Okay? Remember, when you have curves, you need to be careful about the third question, about the guess. Make sure you put the cursor close to the actual intersection. So the answer in this case is going to be 3.36, 2.54. 3.36, did I round correctly? Yes. 2.54, yes. Okay, and that's it for this problem.